So these first four are just a review of, basic fraction operations. If you had 84 over 20 and it said simplify, what would you do? Divide by 4 on the top and the bottom. Okay, and so you would get 21 over 5. Could it go any further? Why? Why can't it go any further? Is it because they don't have a greatest common factor? Actually, they don't have any common factors, right? Not a greatest common factor, but they don't have any. So you know it's as simple as it can be because there are no factors that are common to both 21 and 5. So it's done, right? It's as simplified as it can be. Okay, when we're adding these fractions, 4 over 5 plus 2 over 3, what do we need to do? You have to have the same denominator, exactly. So you need to get a common denominator. If you have 4 over 5 and you have 2 over 3, what is going to be the common denominator? 15. Okay, so if we're going to make this 4 over 5 something over 15, actually move this up. What do we need to do to the bottom to get it to be a 15? Multiply by 3. But if we are going to multiply the bottom by 3, then that means what do we have to do? Multiply the top by 3. So on the top, I get 12 over 15. Now, I know you probably don't write out all of those steps anymore, but there's a point to why I'm breaking it down like this, because once we add in all of these exponents and all of this crazy, variable stuff, the rules are exactly the same. You need a common denominator. How do we get the common denominator? We multiply the top and bottom by the same thing. Okay, so it's good to kind of keep this in mind. All right, so to get this to be a something over 15, I would have to multiply top and bottom by 5, right? So we're going to get 10 over 15. What's my answer to this one? 22 over 15. Remember that the common denominator will end up the same denominator in your answer as well, right? Okay, so number 3, multiply. What do I do here? Do I need a common denominator? No, I multiply straight across the top and straight across the bottom. 4 times 2 is 8, 5 times 3 is 15. That's it. Okay? Divide. How do I divide fractions? Yep. Of what? Exactly, of the second fraction. So I keep the first one, 4 over 6. I switch the second one to 12 over 5. And then what do I do with these two things? Multiply them. So you change the division to a multiplication and you multiply by the reciprocal. So dividing by a fraction is the same thing as multiplying by the reciprocal. Okay, so now I have 4 over 6 and 12 over 5. I could simplify some numbers in here before I multiply. What could I do here? Yeah. For the 12 and the 6, both can be divided by 6. So I can make that a 1 and make that a 2. And then I can multiply. 4 times 2 is 8, and 1 times 5 is 5. And my answer comes out already simplified since I simplified my fractions first. All right. So what does that mean when we make them rational expressions with variables and exponents? Well, it means you do the exact same thing, basically. The exact same rules apply. So simplifying, a rational expression is simplified if its numerator and denominator have no common factors, just like we did with the numbers. So when you look at the first problem here, A, it's in factored form. It's showing you the factors. 4 is one factor, x plus 3 is another factor. On the bottom, we have x minus 5 and x plus 3. So is there a common factor? X plus 3 is a common factor. So we're just going to cancel those out. And we end up with 4 over x minus 5. That's it. You have to remember, though, that x minus 5 is a full unit itself. It can't be broken up. So if I had like a 4x on top, if I had 4x on top and x minus 5 on the bottom, can I cancel anything? No, because remember, you're canceling common factors of the entire numerator or the entire denominator. Is x a factor on the top? Yes. Is x a factor on the bottom? No. So you can't cancel that way. All right, so just be careful that you're thinking of them as the whole factor as a unit itself, and they have to have exactly the same factors to be able to cancel. Okay. So in the box here, there is a full explanation and example. You'll notice that if you had this first example here, the first thing you have to do is factor it. How are you going to know what the common factors are unless you factor it first, right? So there's going to be a lot of factoring involved when we're simplifying rational expressions. So first, and they did this all out for you. So first they factored out a GCF. Remember, when you're factoring, the first thing you want to look for is a GCF. Then they factored what was left. And this all came down to, x plus 2, x minus 1, and x plus 2, x minus 2. So they were able to cancel out the common factors. Notice that this part in front, 6xy to the second over 3y to the third, they broke it all down here. I mean, you don't really have to write it out all broken down like that. It's good for the example. But if I were actually doing this, I would think about my number first. I kind of think of it partitioned, like, okay, 6 over 3. How do I simplify that? 2 over 1. Okay, and then you just make it a 2 over 1. And then x, and there's no x on the bottom. So there's nothing to cancel out. There's no common factor, so I would leave the x. And then I have a y squared over y to the third. How can I simplify y squared over y to the third? Well, the 2 on the top cancel with 2 of them on the bottom, and I'm left with kind of 1 left over on the bottom. Right? So this would just be a y. That would cancel, the x would stay, this became a 2, that became a 1, and I would end up with 2x over y. So that's kind of the way, and you can see that here. So think about it as numbers and then common variables, etc. Okay, so you guys try B and C. See if you can successfully simplify. Okay, so for B, we have 4 over 8, so that simplifies to 1 over 2. We have x squared over x. I always think of, I don't know if everybody thinks of it this way, but I think of there's basically 2 x's on the top and there's 1 on the bottom. And so the 1 on the bottom cancels with 1 on the top and leaves me 1 left over. It's kind of the way I do it. I know sometimes they teach subtract the exponents and whatever. I like to think of it as leftovers. But anyway, and there's no y's on the bottom, so there's just a y on the top. So this is just x, y over 2. For C, again, there's going to be a lot of factoring with simplifying, right? The first thing you want to do is factor the numerator. Factor out a GCF. When you factor out a GCF, you get x on the outside, and what's left is x plus 7 over x squared. So x over x squared can cancel. Again, there's 1 left over on the bottom. 1 on the top cancels. There's 1 left over on the bottom. So you should just get x plus 7 over x. And like I said, now, don't be tempted to cancel those x's, right? Because it's an x plus 7 on the top and just an x on the bottom. And you're canceling common factors. X is not a common factor on the top, right? X is not a factor on the top. So you can't cancel it with the x on the bottom. Does that make sense? Yes? So that's simplifying. Moving on, adding and subtracting rational expressions. You need a common denominator, just like you did with the regular old fractions. You need a common denominator. So, here's your explanation. Isn't that clear? There you go. Go ahead, do it. Go. All right, so let's do one actually together on the next page. All right, so I'm actually going to start with, we'll start with B. We already did one with plain old numbers, so we'll skip A. Let's start with B. So when you look at the three denominators, x, x squared, and 2x, you have to come up with what the common denominator is. Okay? Now, if I broke this down, this would be x, this would be x times x, right? I'll put them like this, and this would be 2 times x. So we need a common denominator that has all of those factors in it, basically, right? So we need a 2, we need an x, and we actually need an x squared because just an x wouldn't be enough, right? So you need the greatest common factor of the numbers, right? So this is 1, 1, and 2. What's the greatest common factor of 1, 1, and 2? 2. Greatest common factor. Sorry, I really did say that wrong. Not the greatest common factor. The least common denominator, right? That's what you're really looking for, the lowest common denominator. So of 1, 1, and 2, the lowest common denominator has to be the 2, right? That's not the GCF. It's the lowest common denominator. Think about when we had 3 and 5 as our denominators. You needed the lowest common denominator, right? It's really the LCM, the least common multiple. Remember, so you're really multiplying them to get the lowest common multiple. The least common multiple is what you used to, in middle school, you learned GCF and LCM. Remember learning those two things? So this is the LCM. The lowest common multiple gives you the common denominator, right? So think of when we had 3 and 5, we had to actually multiply 3 and 5 together to get the LCM, right? The lowest common denominator. So with 1 and 2, you have to multiply them together, you get 2. Okay, so now you have x, x squared, and x. Again, we need the least common multiple. So we're going to have to take x squared as our common denominator. So 2x squared is going to be our common denominator. So when we're adding these three fractions together, all three of them should have 2x squared as their common denominator. Just like with the 3 and the 5, we had 15 for everything. And then, if you remember back on page 1, right, what did we do to the top and the bottom to get 5 to be a 15? We multiplied it by 3. So we're doing the same thing here. Look at your first fraction. To get x on the bottom to be a 2x squared, what do you have to multiply by? So you have a 2 on the top already. Right? You have a 2, it's already sitting there on the top. On the bottom, we had an x. In order to get the bottom to be a 2x squared, we have to multiply, I'm running out of colors here. We have to multiply the top and bottom by 2x. Right? You got to, whatever you do on the bottom, you got to do the top. And if we want the bottom to be a 2x squared, we have to multiply it by 2x. If we multiply by 2x on the bottom, we have to multiply by 2x on the top. Now look at 3 over x squared. I don't know why I can't move this over. what do we have to multiply the bottom by? X squared. What do we have to multiply that by to get it to be 2x squared? 2. So if you multiply the bottom by 2, you have to multiply the top by 2. And the last one is 1 over 2x. If you multiply, what do we have to multiply on the bottom to get it to be 2x squared? Just x. So if we multiply the bottom by x, we have to multiply the top by x. I forgot to start my video. Okay, so we have just x on the top. Oh, no, it's there. I did start my video, sorry. Okay, so now, for this problem, I've got 4x plus 6 plus x on the top. I'm gonna go up this way. 4x plus 6 plus x over 2x squared. And 4x plus 6 plus x can be written as 5x plus 6. Just change that to 5x plus 6 over 2x squared. And that's your answer. Yes. Yeah, so you do want to check and see if you have any common factors at the end, but the truth is, if your fractions were all simplified all the way through, you shouldn't end up with any common factors at the end with one like this. Okay. Okay, so again, what will our common denominator be? What would be the lowest common denominator or multiple of 2 and 1? Again, 2, and x squared. X squared. So we have the same common denominator that we did before. So for the first one, what would you have to multiply the bottom by to get 2x squared? X. So you're going to multiply the top by x. And I'm going to write the result here, x squared plus 4x. For the second piece of this, what would you have to multiply top and bottom by? 2. So you're going to get 2x minus 2. Now, we're subtracting, so you have to remember to distribute this negative when you get your numerator here. So your denominator is still going to be 2x squared. You're going to have x squared plus 4x. Remember to distribute this negative now. Minus 2x plus 2. Most common mistake ever would be to forget to distribute that negative. Do you guys see why that's a plus 2? Yes? Okay, so now we can simplify this. We get x squared plus 2x plus 2 over 2x squared. All right, I'm gonna have you do, no, I'm not. I'm gonna do E together with you. Then I'm gonna have you do D on your own. Okay? All right. All right. Here we go. X squared plus x minus 12. What do we have to do before we can figure out what the common denominator is? What do we have to do first? Factor. Factor, 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 factor. Right? You cannot figure out how things get multiplied together unless you break it down first. Right? So first thing we're going to do is factor. This is why we don't bother doing boxes and x's if we can help it. This will take you so much longer. If there's an x squared in front, we know the first term of both of these have to be x. Now we're thinking what multiplies to be negative 12 and adds to be a positive 1. 4 and 3. And since we want it to be a positive 1, it has to be a positive 4 and a negative 3. Okay, so this fraction has a denominator of x minus 3, x plus 4. And the other fraction has a denominator of x plus 4. So remember what you're going to do here. You're going to think to yourself, what do I have to multiply this denominator by to get whatever common denominator we come up with? So the common denominator here, this has an x minus 3 and an x plus 4, and this is just an x plus 4. We have to get the least common multiple of this. Well, that's going to turn out to just be x minus 3, x plus 4. X minus 3, x plus 4. So if you come up with a common denominator, you can kind of check to make sure you're on the right track by asking yourself that question and making sure there's an answer. And the question is, what do I have to multiply the original denominator by to get the common denominator? Well, what do I multiply this original denominator by to get this common denominator? Just 1. So nothing changes on the top. But then we come to our second fraction. What do we have to multiply this original denominator by to get our common denominator? X minus 3. So on the top, we're going to do 6 times x minus 3. Definitely should have left you more room. Okay, so I'm going to go this way now. I get 3x. Well, this is 6x minus 18, right? So I have 3x minus 6x plus 18. Remember, we're distributing that negative. Over x minus 3, x plus 4. And we do have to simplify the numerator. 3x minus 6x is negative 3x plus 18 over x minus 3, x plus 4. But the good news is you don't have to multiply that back out. You can leave your common denominator in factored form. All right, so you guys try D.